All right, so we are doing lesson 6.2 today, and it is analyzing reflections. So remember yesterday when I drew that pretty little umbrella, and on the umbrella it was transformations. That was the big overarching name for all change. Yesterday's change was the slide or the translation. Today is the reflection, also known as a flip. So if you see on the instructions to flip, it means reflection. Okay, and we're going to talk about what a reflection is, but that's what that means. All right, so I'm going to put this up here for a minute, let you guys have a chance to get this written down. This is some things about a reflection that I want you to remember. All written down? What are you doing? Can I talk to you? Okay, if you don't have it all the way written down, don't worry. At the end of notes, I will scroll back up and I will just leave this on the overhead at the end of class. Okay, so if you're not done, don't worry about it. We are going to go ahead and move on, but if you're not done, you can get these later on at the end of class. All right, so reflections, there's a little bit of similarity and a little bit of difference with translations. The first thing there under reflections says they stay the same shape and size. That was the same as yesterday, right? They stay the same shape and size, and that means all angles and all side lengths are the same. Okay, they don't get bigger, smaller, they don't change shape or size in any way. Number two is that they reflect or flip over the line of reflection. And I will tell you this, if you're a highlighter person, get them out. If you'd like to be a highlighter person, this would be the paper to do it on. You can borrow one of mine, because you have to highlight or make stand out the line of reflection on every single problem. So if you want to grab a highlighter, go ahead and come grab one. I'm going to show you on your notes what to highlight. So with every problem where it is a reflection, you're always going to want to highlight this line of reflection. Okay, right here. So you'll notice that do this without talking, please. Hopefully that didn't mess up the recording. What you'll notice is that your pre-image and your new image, right, or the transformed image, are going to be the exact same distance from that line of reflection. And you'll notice in that bottom line, I've got LOR in parentheses. I am totally fine with you abbreviating the phrase line of reflection, because you're going to be writing it a lot. So if you want to abbreviate it LOR, I'll know what it means, you know what it means, and we're good to go there, okay? All right, so let's look at this first up here, this solve it. And I've really already done it for you, but you can kind of fill in the blanks with what I'm going to talk you through. So they give you the black image, and then they give you the one line on the new image, right? The translated or the transformed image. And they want you to fill it in with the rest of the triangle. Well, with a reflection, it's different. A translation, if the triangle's pointing to the left, when you get it moved around, it should still be pointing to the left, right? It stays the same, everything, it just changes location. With a reflection, you got to think of it like a book, okay? The pencil in this case is the line of reflection because it says that it reflects over the pencil. So if you think of like the spine of a book, right? If you open a book, the spine of that book is the line of reflection. And the main thing that you want to remember is if you look at this right here, this outside blue vertex on the original pre-image, it is 7 spaces from the line of reflection, which is the pencil. That means that on the other side of the line of reflection, it needs to be 7 spaces away in the other direction. And that's what causes that reflection. Okay, same thing for the other points on the triangle. If you look at this bottom point, I'll do it green. It is 1 space from the line of reflection. Therefore, the second point or the other point has to be exactly 1 space from that line of reflection on the other part. And then if you look at the purple one at the top, notice that that point is 1 space to the left of the line of reflection. And so you have 1 space to the right of the line of reflection. Okay. And as long as you reflect each point individually, when you reconnect the dots, you will get an image that is an exact mirror of itself. Okay. So a bit different than translations. For those of you watching the video, this isn't really going to help you, but for those of you in class, I've got a visual here. So yesterday we did translation. And yesterday when we did translations, okay, we said, I'm a little too short for that. There we go. We won't bet this video then. Yes. You don't have to. Okay, so yesterday when we had translations, we had okay, okay, try one more time. Yesterday, if we had this as our pre-image or our original image, and we translated it, notice the pointed bottom part is heading left. If we translate it and move it, we put it in a different location, but this part is still pointing backward, it's still pointing up, nothing's changed. The difference on today is that if we call this point A, and point A is this lower outer tip, when we reflect it, notice point A is still the lower outer tip, right? But the outer side and outer side are exact mirror images of each other. 7 spots from the reflection point or line, 7 spots from the reflection line. Same thing with point B, right? Point B is the closest to the reflection line. So when you reflect it, it's 1 spot away. It's still closer than A, right? It's still, so it's different because when you were translating, if the lower right or if the lower left corner was A, the lower left corner was always going to be A. If the upper one was C, it's always going to be C. With this, your points are not going to be exact like they were yesterday. They're going to be exact opposite, okay? And they're going to flip. If your line of reflection is an axis, your y-axis or your x-axis, then all that changes is, in this case, your x value would go from a -7 to a +7. Now here, our line of reflection is a pencil. It's not an axis. But if this were the y-axis, your y would stay the same on both of these points, but your original one would be -7, and your prime one would be +7. So notice what changes is the y-axis. Okay, we'll talk about that more in a minute, but that's just kind of a good introduction into what a reflection looks like. All right, so let's look at example number 1. And we're back to that client who's got an architect working on his house. It's the same picture from yesterday. And it says the client wants the architect to flip. There's that word flip. So when you hear flip, you need to think reflection. Okay. you guys put your Chromebooks away for me, that'd be great, everybody. So when you see the word flip, you need to think reflection. Putting it on the other side of the patio, where does the client want the grill placed? Well, if you could fold this patio in half, which you can't obviously, but let's just say it's a cardboard patio, and you put a little dotted line right down the center, and you fold it in half, and you let that grill flip over to the other side, that's what we're doing here. So that's what they've done here, is they have put a line of reflection. And I would highlight this. This is the importantest. It's the most important thing you're going to notice on every single problem that is a reflection. You have to know where the line of reflection is. And you really, if it's on paper, you need to put it on your paper with a highlighter or a pencil or something to know that it's there. Now, notice they have done that. They have taken their porch and they have put this dashed line right down the center. It's the imaginary line that is the line of reflection. So that's the spine of the book, right? That's where it's going to open and close from. And the grill, when it is flipped or reflected over the line, notice that it is the exact same Notice that it is the exact same distance from here to here as it is from here to here. From the original to the line, from the line over to the new. Okay, it's exactly the same distance. And then on that try it, they wanted you to also reflect the table. And so that's what I've done there in blue. The original table was here. Okay, I reflected it over, keeping the same as best I can freehanding, but keeping the same size and shape and trying to get it the same distance from that line of reflection. Now you guys are going to have like grid paper and grids to do this on, so you can be exact, whereas I can't really be exact on this drawing, but you kind of get the idea. The line of reflection is a line over which the figure is reflected. The original location and the new location of the grill are the same distance from the line of reflection, okay? And I've got just that little note that it is like the spine of a book, okay? All right, so we've already done that. Try it. We've reflected. This is what I really want to highlight, though, under this try it. If you're using a highlighter right now, I want you to highlight the words across the center line. Every single reflection problem you do, before you even put pencil to paper, you've got to look for the instructions of where the line of reflection is. Or if you're given two images, you need to stick the line of reflection in the middle, okay? So very first thing, every single time when you see the word flip or reflection, you need to think, where's my line of reflection go? It's in the direction somewhere. Either they've given you two figures and you have to put it in there, or they've told you where it is and then you have to reflect a figure. But you cannot do reflections without a line of reflection, okay? So how do the pre-image and image compare? Okay, this is from that page, first page that you guys wrote it down. They're going to be the same size and shape. They are going to be flipped over the line of reflection. And what that changes, and I don't have it here, but what that changes, it changes two things. One, it changes the location, right? Which we're used to that. Translations did that too. But it also changes the orientation. And what that means is the direction that it sits. It's upside down, okay? Or flipped over. And if you think about somebody getting disoriented, right? They're kind of like out of sorts, maybe dizzy. They're not seeing things straight. And if you get somebody oriented, they kind of straighten back up. So if something has changed orientation, it's off kilter, or it's in this case, it's flipped over. Okay, think of a turtle, right? You disorient a turtle, what do? You flip them over on their shell. So when you have a reflection, it flips or reflects over the line of reflection. And not only does it change location, but it flips itself over on its backside, if you're still thinking of the turtle. Okay, sound good? All right. So let's look at example number 2. So you're going to have problems like this where you are going to have to graph the original, the pre-image, and we're not going to do that. They've already done it for us, but those instructions are right here, right? Here's the vertices of the original one, and they've already graphed that in black for you. And then they want you to graph and label the vertices of the prime image, okay? And here's what you got to do. Before you can even begin to do this, you have to hunt for the sentence of what you're reflecting over. In this case, you're reflecting across the x-axis. So before I do anything, I'm going to go to my graph and I'm going to highlight the x-axis because that's my line of reflection. And that's what your whole problem is pivot or whole pivots on is this line of reflection. Okay. Now I've color coded it just so that you can see where everything goes. And I'll just point out a few of them. I'm not going to do every single one of them, but if you take original E, right, which is this blue one right here. If you take original E and you count how many blocks it is from the line of reflection, okay, it's 1, 2, which means you're going to go 1, 2 and drop your point and label it E prime. Now, if you do the little humpties to make the bounces, please erase them. They will make your graph an absolute mess. So I put them on there so that you can see what I'm doing. If you need some sort of tick mark or something to count, erase it when you're done, because you don't want your problem to be just this crazy mess of bouncing lines and dots and all of that. Okay. So same thing with D. I'll do it and then I'll erase it. I go to original D, which is right here, and I count 1, 2, 3, 4, 5. I land on that line of reflection and it was 5. So I go the other way. 1, 2, 3, 4, 5. I land it and I name it D prime. And you have to do that with all 5 points. You can't just do it with a couple of them and then freehand the rest. It doesn't work. If it has 2 or 3 vertices, then you need to count 3 vertices into a new position. If it has, and that's with translations, reflections, that's really all of them. If it has, in this case, 5 vertices, then you need to count 5 different points into their new location, all of which hinge on or reflect over that line of reflection. Okay. When you're done and you connect the dots, you should have a nice, perfect, same size, same shape, flipped upside down, okay, over the line of reflection. And you'll notice that the E and the A were the closest to the line. In the reflection, E and A also need to be closest to the line. You'll notice that C and D were furthest from the line. C prime and D prime also need to be furthest from the line. That's what a true reflection is. Okay. Notice this. Corresponding side lengths and angles remain the same. You already wrote that on that other piece of paper. I just want to bring it to your attention again. Okay. We're not going to do the try it because you would need graph paper. So we're going to go ahead and skip that for now. And we're going to go to example number 3. Now I've already done it, but I'll erase it and do it again here. So it says, what is a rule that describes the reflection that maps parallelogram ABCD onto ABCD prime? Okay. It says parallel, a reflection maps every point of ABCD to the corresponding ABCD prime. Parallelogram, and that's telling you what it does. Okay. Now, in this case, you have to ask yourself, it doesn't give you a line of reflection, right? So you've got to look at the 2 images and you've got to ask yourself, how are they reflecting? Well, check A and A, compare them. What are they doing, right? They are equal distance, and you can see they have it in green and orange or green and red there. You want your line of reflection to go straight down the middle of the 2 shapes. And in this case, it won't always be the y-axis, but in this case, there's your line of reflection right there. To get from A, which is ABCD, that's your original one, over to the prime, you reflect over the y-axis. So if you're just given the shapes and you're asked to describe what's happening, you need to recognize that because B is on the outside and B is on the outside, D is on the inside, D is on the inside, you need to recognize that this is one that was flipped over on itself, which means you would need to recognize that this is a reflection. Okay. All right. So the answer that you would put right here is what I have highlighted in red, a reflection across the y-axis. That is the transformation that happened to create ABCD prime. And what you're going to have eventually is you're going to have one like this. And you're going to have to say, is this a reflection? Is it a translation? Is it a dilation? Is, what's the other one? Translation, dilation, rotation. I think that's my other one under the umbrella. Is it rotation? So you're going to have to be able to compare points, compare positioning, and then decide between all of our different transformations. And the real tip off to a reflection is when you've got outside B. That shows you that B was on the outside, and when it flipped over, now it's clear on the other side. That kind of is your tip off that it's a reflection. Okay. All right. Let's see. I've got this highlighted to bring it to your attention. When you are reflecting across the y-axis, now this only works if your reflection point is the y-axis. If your reflection point is a pencil, this doesn't work, like the first example. If your reflection point is x equals -2, which we're going to do in a second, then this doesn't work. But if you'll notice, your x's or your y's stay the same, and your x goes from positive x to negative x on a reflection. That only happens if it's reflecting over an axis. Y-axis, your y's stay the same, but your x's change. Your x-axis, your x's stay the same, but your y's change. Okay. All right. So this one is the one I want to really do as far as to try it, because I want you to notice something. It says polygon ABCDE is reflected across the line. It's not an axis. Don't always just knee jerk to your line of reflection as an axis. It does not have to be. So I have to put my line of reflection at x equals -2. Well, that's right here, because here's x equals 2. And my line of reflection sits right over that x equals -2. So notice now, does that y-axis mean anything at all to you in this problem? You can ignore that it's even there. It means nothing. The only thing that's ever important is your line of reflection. Now, if I reflect my points, point A, 2 from the point, right? I'll do it, then I'll erase it. 2 from the line of reflection. So I'm going to bounce 2 in the other direction. And I'm going to plot a point right there. And I'm going to name it A prime. Then I'm going to go to B. B is 1 space from the line of reflection. So I go 1 space on the other side and I name it B prime. C is also 1 space. So I go over to the other side and I name it C prime. D is 1 space. Nope. D is, sorry, I was talking and not thinking. D is 1, 2, 3. So that means I'm going to bounce 1, 2, 3. And I'm going to put that point right there. And I'm going to name that D prime. And then last, we've got point E. Point E is also 1, 2, 3. So I'm going to go 1, 2, 3 and name it E prime. And now when I connect these, it should produce an exact mirror image of the image that I have over on the other side, which it does. And notice that y-axis does not mean anything at all to us in this problem. You can forget it's even there. The only time it's important is if it happens to be the line of reflection. Okay. All right. So that is everything on the notes. The one thing I want to show you is, look at one like this. This isn't part of your homework. This is just one I want to show you. If you're asked to draw the line of reflection in here, where would you draw it? Up and down or sideways? Sideways, where at? At y equals what? There you go. There's your line of reflection. It's got to be exactly in the middle of the two shapes. Okay. All right. Your homework, pay attention, please. Your homework is page 319 and 320. You are going to do all of them, except you can mark out number 12. Okay. For those of you at home, email me if you have any questions.